Okay, you give the start signal.
3, 2, 1, go.
Okay, so again, hello from Berlin. My name is Benjamin Drost, and I'm here in the TrustedIoT project together with Emmanuel, which is in the audience. And we are both research assistants at the GFAI. So that's an institute working at the intersection between research and industry. So, and our department mainly focuses on subjects in the field of robotics, so like image processing, machine learning, and robotics. But to get back to the main application for this conference or for TrustedIoT, the need for secure systems at our client sites is getting more important with each day. So, and we implemented and also shipped several solutions in the field of robotics to customers in Germany and also worldwide. So for example, paint spraying applications for window frames or wash basins. And all these robotic applications are implemented in offline programming. So these robot applications are not taught beforehand, but the robot itself is controlled in a 4 millisecond interval by the PC directly. So, and in this direct control, there are real life dangers for humans working in the area or in the range of the robot or in the robot cell, so to say. Since if this system is getting intercepted or hacked, you cannot predict how the robot will be moved, will move in the future, or will regard the robot cell as it was implemented in the first sense. So, and that's why we came up with a secure network consisting of sensors and actors. So sensors in the field of robotics like cameras or laser scanners and so on. And on the other side, the robotic side, you've got actual industry robots or like 2D actuators and so on. Yes, and each component will now be wrapped with a kind of doorkeeper. So you can see each sensor and actor is guarded with a client, and this client ensures the secure communication between the server and the actor or sensor. And for the client, for the doorkeeper, we chose the Raspberry Pi or any other single unit computer. So for a more mobile solution. And in this case, the Raspberry had to be extended with a TPM, so a trusted platform module. And these TPMs are getting more common, especially with the forced push by the Windows 11 upgrade. And I think every notebook now has a TPM integrated. Yes, and so we implemented this TPM solution and also checked it that the communication between the Raspberry and the server is really secured by Wireshark, and we could see that each packet, each TCP packet was securely channeled through this, was securely channeled. Right. For the communication itself, we used a software, so-called SoftEther VPN, and this is a multi-protocol solution with which you can tunneling different protocols, especially in the robotic field like Modbus or CAN bus and so on, through the secure channel. For the hardware side, you have to also secure the root of trust. So even the Raspberry itself has to be secured. And as Laurent already mentioned, you have to also focus on the bootloader part. The problem for the Raspberry Pi side is that the actual first stage bootloader for the Raspberry is closed source. So there are attempts at reverse engineering also this first stage bootloader, but they're currently not in a real working state. So we're more or less focused on the second stage bootloader, and this got support. So this got TPM support, and in this, with this support, you can be sure that the Raspberry itself booted securely, and for other modules similar to Raspberries, there are also solutions for the first stage bootloader. So the hardware side is secured. And for the software side, I already mentioned that we are using a software called VPN software called SoftEther, consisting of a server and a client. So not to be confused with the server in our network, but this is this terminology of SoftEther. So, and the SoftEther client sits at the robot side, and the Raspberry or the server starts the communication. And so in this regard, the actual data with which you can control the robot or read out the sensor data will be tunneled through this network via a secure SSL communication channel. Right. So for the implementation, shortly, we've got an UR robot, and the use case was defect detection on workpieces like turbocharger housings, as you can see in this example. So these housings got scratches and marks from the production, and problem is that if you inspect them manually, they are quite heavy, like 10 kilograms. And if you do such inspection work manually for like 8 hours a day, you can expect quite strong forearms. And that's why an automated solution for defect detection is in the need. And what we got here is, on the image processing side, we got up with a solution like a reference comparison. So you've got the OK turbocharger housing as a reference, and to be compared with the current housing, finding marks, finding interesting points to line them up. And in the end, you got an overlay, so or like a super imposition of both images. And now we can take the image difference, or first you have to filter out any references not belonging to the turbocharger housing. And then you got a difference image where you can see actual scratches. In this example, we still have to be, don't forget to have reflections and lighting. So these are other problems, but otherwise, we got another example where you can see actual differences. Here we got washing machine panels as the introductory example. And if you can compare them, you can see that, for example, in the top right corner, the Series 8 is missing on the left panel. So this is for the production. So this is one example for a use case, which then in the future will be secured via this Raspberry TPM VPN solution. And these solutions will be getting implemented in the customer side and also we got requirements for real-time applications. So for example, the 4 millisecond interval, and that's why the security has to be more computationally advanced than a simple Raspberry. And this will be the future work in this project. Thank you for your attention. Are there remarks, questions?
Ross? Questions from the room or from online? I don't see anything raised. Benjamin, maybe later on. Have you tried to present this to some robot manufacturers in this case?
You mean the security part?
Yes.
Actually, no, but
Okay.
there are already some discussions between the customer side and our side, but not in the official presentation that there will be any implementation. But I think these will become more and more important in the future.